So we have already done a system of equations where we used elimination with two variables, right? So the difference this time is that there are three variables, okay? So the first thing we need to do is, before we even start doing elimination on this problem, is we need to talk through and decide which variable we're going to eliminate together, okay? And this is something you need to do at the beginning of every problem. So if we look at the x's and the y's and the z's, let's start with the x's. Now keep in mind that if I'm going to solve by elimination, I'm going to have to eliminate the same variable twice. I'm going to have eliminate, the very first time we do it, I'm going to have to eliminate the same variable twice, two different times. Okay? Because if I eliminate a variable twice, I'm going to have first of all, if I eliminate it once, I'm going to have an equation with two variables in it. And if I have two variables, how many equations do I need to solve it? Two, right? Okay? So that's why I'm going to have to eliminate it twice, because then I'll end up with two equations with the same two variables in it. Okay? So if I look at the x's, I've got a 2x, a 5x, and an x. Well, that's nice. It's nice when we have an x, because then to eliminate the x's, I would have to multiply this one by -2 and add it to the top one. And then I'd have to multiply it by -5 and add it to the middle one. Does that sound like it would be something hard to do? No, that's probably pretty nice. Okay, let's look at the y's. Would the y's be easy to eliminate? Well, what would I have to multiply this y by? 4, first of all, to add it together with the bottom to eliminate the y's. And what else? -5, right? So -5, so I could eliminate the middle one. So again, is that hard? No. Which one would be easier, x's or y's? Right now, x's would probably be easier, right? Okay. Now, what about z's? So I can multiply both of them by -5, right? And combine it with that middle term. Couldn't I multiply the top one by -1 and combine it with the bottom one? You could, right? But multiplying both of these by -5 would also work, wouldn't it? Okay. So which variable do you think would be the easiest to eliminate? The z's? Okay. Could I choose any of the variables to eliminate? Yes. So just because I'm doing this problem for you on the board today doesn't mean, and the way that we do it doesn't mean that's the only way to do this problem. You okay with that? Okay, so if we're deciding to eliminate the z's, first of all, what should we do first? We want to eliminate the z's. Okay, so we want to multiply the top one by -1. I'm just going to write it right out here beside that. Are you okay with that? -2x minus y minus z equals -12. If I multiply the top by -1, what am I doing with it? I mean, I just did that. Now what do I do? To the bottom one? Okay, so I'm going to just rewrite that right over here. Okay? X minus 4y plus z equals -21. So I'm just going to combine those two. So -2x and x, -x, -y and -4y, -5y, -z and positive z, perfect, -12 and -21, -33, okay. So now what? I start over, right? I'm going to ignore this for just a second. And I'm going to go eliminate z again. Okay? Now I'm not going to use the top and the bottom because I just used the top and the bottom. Okay? So what am I going to do instead? Middle and the bottom? Okay, so what am I going to have to do to the bottom equation? -5. I'm going to write it right down here below it. -5x minus 4y, except it's not 4y, it's plus 20y, minus 5z equals 105. I multiplied the entire bottom equation by negative 5, right? So negative 5x plus 20y minus 5z equals 105. What am I going to do with that again? Whoa, whoa, stop wowing me. What am I going to do with this one? With the middle one. So I'm going to rewrite the middle one right down underneath. How do you know that? Okay, so this is 0. This is 25y. That is also 0. That's what I was trying to do. It's almost like I accidentally eliminated the x's too, didn't I? Obviously it wasn't accidentally. You know what I'm saying. Okay, good. Now what? Now I just solve for y, right? Y equals 125 divided by 25? 5, okay. So that's all fine and good and exciting, but what do I do with it? Where? Oh yeah, to this one right here, right? I'm going to take this and go up there. So negative x minus 5 times 5 equals negative 33. Negative x minus 25 equals negative 33. If I add 25 to both sides, negative x equals 8. Negative 8. X equals 8. Does it matter? It doesn't matter. Is there one that's easier than the others? Maybe the bottom one? Maybe the... So maybe either top or bottom, and I would choose top or bottom because I'm trying to solve for z now, and in both top and bottom, z is already by itself. Okay? So does it matter? Which one do you choose? Top one. 2 times x, which is 8, plus y, which is 5, plus z equals 12. Well, 2 times 8 is 16, plus 5 plus z equals 12. 16 and 5 is 21, plus z equals 12. Z equals negative 9. That's my answer. 8, 5, negative 9. Is it the correct answer? We should, right? Okay. 2 times 8. So 16 plus 5 is 21 minus 9. So that one works, right? Okay. Uh-oh. 40 plus 25 is 65. Minus 45 is 20. 65 minus 45 is 20. Okay. 8 minus 20, negative 12, plus negative 9 is negative 21? Yes. Is this the right answer? Yes. Without a doubt. Okay so far? Yes. So let's do this problem. I'll give you a minute to copy it down. Can I talk at you while you're copying it down? Systems of equations. What's wrong? Are you going to write that big again? No. Right on the back. Systems of equations is one of the real things that we talk about in Algebra 2. And what I mean by that is it's something that you actually might use in your real life of Algebra 2 stuff. I told you at the beginning of the year, some of the stuff that we do in here, you won't ever use again. But I have to teach you because the state says I have to teach you. It's on my list of TEKS, stuff I have to teach you, right? And I told you at the beginning, I would let you know if you're going to use it or not. Okay? This is something you actually might use. It is actually something I have used in, at my house to try to figure out some stuff. Now, we're not to the applications yet. We're still to, can we know the process? So I need you to trust me for a couple days that we're going to get to the applications and you're going to see how this stuff can be used. Can you do that for me? Okay. So let's work on the how. Let's talk through our variables first. Okay? Talking through our variables, what do you want to eliminate first? Well, look at the x's. That's pretty good, right? I already have opposite signs. And then a 2, right? So that would be pretty easy. Look at the y's. Not too hard, because I could multiply this by -2 and then a -3, right? Again, not too hard. But z's and x's seem like they would be a little easier, because they already have like exactly the same number but opposite signs. They both do, right? So the difference is this other one is a +2 and this other one is a -2. Sir, ask me.
If you multiply the top equation by -1, you get -x and +2x. Could you combine all three?
You can't do that. You only want to do 2 equations at one time. Okay? It's a good thought, but you only want to do 2 equations at one time. Okay? So which one do you want to choose? X's or z's? X's? Okay, so if we're doing x's, what should we do first? Why can't we just add the top 2 together? Wouldn't that eliminate this? Okay, so if I'm adding the top 2 together, I'm going to get 3y minus z equals 7. I need to eliminate x again. I can't use the top 2 again because I already used the top 2. The middle and the bottom, multiply the middle by 2. Okay, is it okay if I multiply this one by 2 and write it right below it? So -2x, so I'm multiplying that one by 2, plus 4y plus 2z equals 4. Is that what you got? That's that times 2. That's that times 2 times 2 times 2. Okay, now what? Combine these two. So that's 0. That's 7y, correct? Plus the, oh, that's so nice. Why is it so nice? Look at the z's. They're already opposite signs. Can't I just combine those two together?
Yes.
Do I ever want to combine 2 equations together if one of my variables doesn't go away? No. I never want to combine 2 equations together without one of the variables going away. Okay? I wouldn't just combine the second and third because that's not going away. That's not going away. Well, that's going away, but here's the deal. If I've already eliminated the x in the first equation, eliminating the z is not going to help me. It's not going to help at all. So if I'm going to eliminate the x, I need to eliminate the x twice. If I'm going to eliminate the z, I need to eliminate the z twice. Okay? Because see, what it left me is 2 equations with the same 2 variables. And now I can use these 2 equations as if it was its very own system, like we talked about last week, where we now eliminate one of these variables. Does that make sense? And in this particular case, I already have same number, opposite sign. I can just straight add them up. 3y and 7y is 10y. 7 and 13? 20. Divide both sides by 10, and I have my value for y. Perfect. Where? Where do you want to plug it in? Top equation like up here? Oh, like right here, right? Which one would you choose? This one or this one?
The top one.
You would choose the top one? Okay. Why would you choose the bottom one instead? Yeah, z's already positive, right? They said the top one though, so I'm gonna humor them. Plug it in the top one. Not really humoring them because it's really, you can get the answer. So 3 times 2 minus z equals 7. So 6 minus z equals 7. Negative z equals 1. So what does z equal? Negative 1. Look at this. 14 plus z equals 13. If I subtracted 14 from both sides, I get z equals negative 1. I'm going to get the same answer no matter which one I choose. If I plugged it in right here, if I said 14 plus z equals 13, if I subtract 14 from both sides, I got z equals negative 1. Same thing. Do you have to plug it into both of them? No, I was doing it to make a point. Okay? You just have to plug it into one. You're going to get the same value no matter which one you plug it into. So I know y and I know z. Where? Any of them. Which one would you choose?
Probably the middle one.
You would?
Yeah.
Okay.
Or maybe the top.
Why would you choose the top one?
Because it's already positive.
X is already positive. Okay. So, but could I choose any of them? Yes. So x plus y, which is 2, minus 2 times z, which is negative 1, equals 5. So x plus 2 plus 2 equals 5. Does anybody know what 2 plus 2 is? X plus 4 equals 5. So x equals 1. How many of you could see the answer without writing down that step that I just covered up? So is that step required? No. Okay. So do I have an answer? What is it? 1, 2, negative 1. Is it correct? Okay, let's check it. 1 plus 2 plus 2 is 5. Okay. Negative 1 plus 4 is 3. Plus negative 1 is 2. Okay, that one's right. 2 plus 6 plus 1. Is this the correct answer?
Yes.
Without a doubt. Okay? Any questions? Elimination with 3 variables. We eliminate a variable and then use a different combination of 2 equations to eliminate that variable again. We end up with 2 equations with 2 variables. Now sometimes we'll get lucky and like on that last problem, when we try to do it again, 2 of the variables eliminated and I got y equals 5, right? Sometimes it'll happen. But if that happens, I still got to go find the other 2 variables. Okay? Sometimes if this happens first, if we would have done that first, we would think, oh, we're done. No, you're not. Gonna have to take this and plug it into 2 different equations to get an equation, or to get 2 equations with 2 variables, kind of like we have right here. Use that as its own system, solve it for the variable, take the 2 variables you know, and plug it in for the 3rd variable. Any questions about that?